Okay, so good morning to everybody. Thank you, Mrs. Chairman, for the presentation. The work that I would like to present today speaks about rice germ, but first of all, I would like to introduce myself because it's the first time that I attend this conference. I'm a postdoc researcher at the University of Genova, Italy. The group is Analytical Chemistry and Chemometrics. We mainly use spectroscopic technique in the NIR region mainly, and also hyperspectral image analysis. We have a group of chemometrics, so we do chemometrics from the both side of multivariate data processing and multivariate design of experiments. Regarding the field, I mainly work on food, but we have also other applications on environmental and cultural heritage. But I'm here today also because I am the secretary and treasurer of the Italian Spectroscopy of the Italian Society of NIR Spectroscopy. We are a very active society, both in the Italian territory, but also in Europe. And if you want to follow our society, here I wrote the website and also our Facebook page, in which I just published some picture of our meeting of yesterday evening. Okay, but what is rice germ? Maybe some of you have already seen a rice germ, but if you have never worked in the milling industry, you have never seen it, because it is completely removed during the whitening phase of rice, because it contains a high content of unsaturated fatty acid that undergoes a very fast rancidity during storage. So what they do is to remove rice germ with a high technology to allow us to store rice for a very long time. But rice germ is the embryo part of rice, so it has the 70% of nutritional value of rice, and the idea is, why not use this rice germ for human nutrition, to produce a new novel food with a high content of nutritionals. So the aim of this work is to understand if we are able to storage this very nutritional product, but with a high content of fatty acid. So we applied, of course, FTNIR spectroscopy jointly with the aquaphotomic approach to understand the effect of water activity on rice germ shelf life. But the global impact of this work is not only focused on rice germ, but the idea is to understand the water molecular structure behind water activity. But what is water activity? Water activity is a very important parameter in food chemistry because it is really fundamental for processing food and storage food. We are speaking about the relationship between the partial vapor pressure of water in our sample in respect to the standard state partial vapor pressure of the pure water. This concept was very in fashion in the 80s and was studied a lot by Labuza, and I decided to present to you this graph that, in my opinion, is very interesting, that shown how the degradation of food is related with water activity. So is the relative ratio of the reactions that we have inside the most common food commodities. Okay, so going into the experimental plan, this is the society that collaborates with us in this project, is one of the most important industry that produce rice in Europe because they are able to storage rice until 20 years. So we have aged rice that is produced in this Italian society. So we decided to start from their rice germ. Remember that is not rice but rice germ, and we applied three level of water activity coded with A, B, and C, and three modified atmosphere or storage atmosphere: air, vacuum, and nitrogen. I would like to underline that the water activity is not water that we added to the sample, but we remove with the vacuum oven the humidity, that is the moisture that is inside the rice germ. Okay, then we decided to store at 27 degrees to accelerate the degradative process for 320 days. We performed 7 sampling dates. The first one is 0, that is the time before packaging, and from T1 until T6 are the sampling date in which rice germ was packed. We have a total of 45 samples. If you do a simple counting here, you can see that are not 45. Why? Because according to the decision of the industry, we packed the water activity with higher level, 0.55, only in air, and also because T0 is before packaging, so we don't have all the 3 levels of packaging. So we made the FT NIR of these samples. We use a rotating sample holder in reflectance with 4 centimeters minus 1 of spectral resolution. A total of 90 spectra, 2 replicates that are not only analytical replicates, but we opened 2 cans of rice germ to do the analysis. Here I try to outline the stairway of the data processing, because I think that is a very crucial step to underline the consistency of the work that I'm presenting. So we start from raw data matrix. Remember that we have inside different water activity, different storage atmosphere, and different time. We have a time trend in there. So it's a quite complex data matrix. From this, we perform a data pre-processing according with the normal flow sheet of Aquaphotomics. We perform MSC, so multiplicative scatter correction on our data, and 2 types of centering that I will show you later. We perform then an exploratory step, of course, with the principal component analysis, and a supervised step with partial least square regression. The joint interpretation of exploratory step and supervised step allow us to extract the variables that are activated in this process. So we define our WASP, and the WASP were represented using Aquagrams, of course. But at the end, we are the chemometrician, so we try to do something more. We apply also a three-way analysis at the end of the data processing stairway. Okay, so starting from data preprocessing, you can see the 2 types of preprocessing that we perform on our data. The pink one is MSC plus blockwise centering. So what we made is to subtract the mean spectrum at each modified atmosphere to the sample treated with the same atmosphere. In this way, what was our aim was to minimize the differences among the different storages. And we had an idea then that was also to minimize differences among batches before the packaging, to have similar rice germ that were submitted to the packaging. And to do this, we make a T0 centering on the top of MSC and blockwise. What is the T0 centering? It's easy because we subtract the spectrum obtained at the same water activity before packaging. So the sample, all the sample with 0.55 of water activity has the spectrum at 0.55 at T0, subtracting from the entire storage time. On the 2 data preprocessing, we perform principal component analysis. So the first line is MSC plus blockwise, and the second line is MSC blockwise and T0 centering. Of course, depending on the preprocessing, is evident that we are highlighting two different stuff. In the first line, the information that for me it's stronger is the one that we can see along principal component 2, in which we have a very strong time trend. I don't know if it's easy for you to see, but we have sample starting from T1 until T6 going up along principal component 2. So we look at the loading for principal component 1 and principal component 2, but of course the one in light blue that are the one of principal component 2 are the one more strong for this principal component, for what we want to see in this principal component. And in the second line we have the T0 centered data, and the group that are colored according to the water activity level, in my opinion, are quite evident. And also, I can underline that are quite evident, in particular along principal component 1. So if we look here on the loadings, first of all, I'm very happy to see the same band as before, but we can do this, but it takes time. We can check that these bands that are in pink, in black here, that are the one related with water activity, here you can see in black that is the same band, and also we find correspondence on the direction of this loading. So we are very happy to enhance these 4 bands from principal component analysis. But we are not happy only with exploratory approach, so we decided to perform partial least square regression. I would like to underline that this partial least square has not the aim to predict the sample, but the aim is to force in a supervised way the selection of the band, adding the information about water activity. So it's a different aim respect to the normal aim of doing a regression. So what we can see, first of all, we can see that these are the 3 levels of water activity, so the dispersion that you can see here is according to the error of the model, but we are happy because we don't have overlapping between the 3 levels. So regarding band selection, we are quite happy about this model. And here you can see the PLS coefficients that allow the most important band in this model, and you can see that the bands that were shown in principal component analysis are here again. And also we have the possibility to underline other 4 new bands that have been added to the most important band of this system. I forgot to say, but it's easy to understand here, that the y-dependent variable was, of course, the level of water activity. So we forced the model in the direction of water activity. Okay, so what we made until now, we had the raw data matrix, we performed MSC, we had 2 types of data centering, we made the exploratory step and the PLS step. Here our 8th band. So what is the meaning of the band? And this was the moment of aquaphotomics, because we check, thanks to the table of the WOMAX, the meaning of our variables. So here we try together with Rumiana to give meaning to these bands, and we were very happy because we have bands that are more related with free water. You have here free water and water solvation cell with a lower number of water molecules inside the solvation cell. Then we have intermediate bands, protein hydration band here, and we have also where is water solvation cell with a high number of water molecules, and also the Zundel cation arise. I have never heard about Zundel cation, was my first time, and so for the one of you that also is also for you, it's new, it's an hydrogen connected with bounded with 2 molecules of water, and this is a way of storage energy for water. And then we have also the trapped water and the strongly bonded water. So our 8 wavelengths are able to describe trapped water, free water, and an intermediate phase of water. We decided to select also other variables inside the WOMAX to have a whole comprehension of the system using also other bands. And here are our aquagrams. So I will present 2 types of aquagrams. This first one is aimed to separate the times, sorry, T1, T2, T3, T4, T5, and T6, so to underline the time trend. What we can see here that, in my opinion, it's interesting. You can see the light blue line. Light blue line is the higher level of water activity. And we underline here a shape of this line. And this shape became even more marked along the time. But the very nice fact is that the intermediate level of activity water is the pink one, and you can see that a long time the same shape is arising. And in T4 we have the shape that we underlined for the blue line here, arise also for the pink line. And at the end of the storage, also the gray line, that was the one with the lower activity level, has the same pattern. So what we are looking at is that the higher the water activity, the stronger the degradation process. The lower the water activity, the lower the degradation process. So we were quite happy about this, because it's in line for what we know about water activity. And another important thing that arises here is the importance of this band. What is this band? This is Zundelcation. This is an intermediate structure of water. So what we understood is that this band is the most characteristic for our system. So something, it's like enhancing the fact that something is happened. It's not something that is or trapped or free, but it's something that is changing along our process, and we were very happy about these results. And this slide, you already seen this slide in the presentation of Professor Chenkova the first day, and here what we made is to separate the water activity and see the behavior of the water activity along the 6 times. So here became very evident that at 0.36 of water activity, we have a behavior that does not change a lot. So our holistic markers for water tell us that it's not so evident what is happening inside water, but it became more evident here with a higher level of water activity. And here you can see that something is happening inside sample with the higher level of water activity. So this is the last step of the data preprocessing. This is Tucker-free PCA. I don't know if someone of you have already applied the freeway approaches, but the idea is to see in a unique orthogonal space the influence of the 3 modes of our system. So water activity, time trend, and wavelengths. So it's very evident here that one of the axes of this orthogonal space explain water activity, and the other one explain time trend. So in this way, we were able to orthogonalize the 2 factors that we were looking at. And also we have the pattern of the wavelength here, so we can check which wavelengths are more related with low level of water activity at lower time trend, high level of water activity at low time trend, and so on. Just looking at the coordination of this orthogonal space. So trying to give you a comprehensive conclusion is that near bands that are related with the less organized water are the ones subjected to the more marked evolution, and their absorbance increase with the storage of rice germ. And the higher, what we can see is that this increment is higher, so the increment that we have along time storage is higher for higher level of water activity. Then we have the Zundel cation that increase with time, and is the most characteristic wavelength of our system. And then we have the trapped water and the water strongly banded that suffer a lower modification along time. So it is possible to say that when water is engaged in strong band, it is difficult that it became available. But during the process, the storage process of our food matrix, we have enzymatic degradation. And this enzymatic degradation can cause an increment of the acidity of the system that helps to release water. We have more water release, the enzymatic degradation increase, and this enzymatic degradation release against water. So in our opinion, this work helps to understand a little bit more about the exponential nature of the degradative process of food. So with this slide, I finish. I would like to thank all of you, and of course Rumiana Chenkova for work with me and invited me to be here, and also domo arigato gozaimasu.
Thank you, Cristina, for the wonderful presentation. So we've time for questions. Yes, Eleanor.
I have just one short question. I absolutely love your presentation.
Thank you.
I always, I think I find it as a sort of like a textbook for aquaphotomics.
Wow,
So
thank you.
I just wanted to know, is this published somewhere, or are you planning?
We are working on the paper right now. It's
Okay.
Yes.
Thank you.
Thank you.
That's all.
I didn't see here clearly about your data processing. What was the blockwise centering?
Okay, so the idea of blockwise centering is to remove the influence of one variable that you don't want to look at. So in our work was the modified atmosphere, because we would like to look at water activity, but the experimentation was bigger, and so we have also the influence of storage atmosphere. So what we made is to say, okay, all these samples were stored with the same modified atmosphere, make the mean spectrum of these, okay, and subtract the mean spectrum of the storage atmosphere to all the samples that were stored at the same condition. In this way, you are smoothing the difference that is between the sample due to the modified atmosphere. Why? Because we want to look at this variable.
Yeah, you do mean the subject is the mean of different group of samples.
Yeah.
So that's makes the difference of the samples bigger. So your classification is very good.
No, it's not. It's not bigger. It's because we need a centering, of course, because
yes.
doing.
But it's better to subtract the whole mean.
Yeah, you can do this if you want to maintain the sample equal in terms of both water activity and storage atmosphere. But I want to be supervised and to try to remove the differences in terms of modified atmosphere, enhancing what you are saying, enhancing the differences in water activity. Yeah. So this is the aim.
It's better to think about your situation. That means doing like you in this way means you know the classification before you did your calculation.
Yeah, of course, because it was in the experimental plan, the difference.
So it's easy to make mistakes.
No, was in the beginning, we had the sample at different water activities, not a classification purposes, because we know the classes before. The classes were inside the experimental plan. So our idea was not to classify the level of water activity, but to understand which were the bands that separate these classes. Okay.
Thank you.
Thank you.
Okay, just one comment. Could you please show the aquagrams with all water activities? Yeah. It was so interesting when you said that the, people at this company are selling this rice, a long storage rice. And what is the water activity? Is it the lowest water activity or the highest water activity?
For sure, they decided to use the lowest water activity because the storage time will be higher, but the product is not right now already sold. It's something that they are again working on.
Because when maybe another slide, when I looked at the aquagram, the lowest water activity gives you such a round, beautiful shape of the water, so you have everything in the rice, which is really, really very logical, and you can see it.
You can see it. Yeah.
Thank you very much.
Thank you.
Thank you.